absolutely fascinating that has also informed my research here, and the theorem prover the French have called COQ. How do you discuss this down the pub with your friends without being laughed at? Seriously. Fantastic code. It's just one of those that the French have naming things. Anyway, so when I first joined the infrastructures.org community, what we had was CF Engine and BCFG. That was basically it, right? And CF Engine is kind of interesting because it does think in terms of convergence, but other than that, you know, it's kind of, it's like, it's nearly 15 years old at this point, and it shows, right? It shows its age way more than my maturity does. And then there were some guys who came up with a thing called ISConf. ISConf was fascinating because ISConf was based on the gold system principle, right? You had a snapshot that was, this is your gold system. And then ISConf had two sorts of actions. Snap, which put one file on the file system at the point desired, and exec, which ran one command. The idea being, if you conceptualized everything in terms of that, you had absolute predictability. And they're right, you did. It was boring, and you couldn't really do anything interesting with live systems, but it was absolutely predictable. And I will point out for the record that the ISConf guys had everybody from market traders to engineers to secretaries on the same baseline platform using this system. So, okay, if they screwed up a single step while testing automation code, they had to restore the machine from backup and start again. But on the other hand, when some nutball decided to fly a plane into half of New York, the ISConf guys had their entire company up and running again in a backup location within about 2 hours. So it's one of those, it might have been boring for the IT guys, but man did the users love it. Or at least the users who were still alive. IT can fix many things, unfortunately it can't fix nutballs with planes. But anyway, so in like 2002 or so, Luke Koenig started talking on that list, and he had this idea for a thing called Puppet. We had the hilarious thing of at the time, he went, I'm going to have to write Puppet in Ruby, I'd much rather write in Perl, but Perl doesn't have quite enough OO for my taste. Whereas these days, I write in Perl because Ruby doesn't have enough OO for my taste. Later on, there was a guy called Holloway. Wrote Catalyst Action Rest and Catalyst Controller Rest. Now, what people probably don't know about him is, he built those in the process of building what he considered his zero-copy Nirvana deployment system. Right? And then he went, I'm writing version 2 of this. We argued for days about what the best deployment system possible should do. And then at the end of it, he went, by the way, this was like 2007, 2008, he's like, I'm part of a systems consultancy, all of my customers are Rails startups. I really wish I could write this in Perl, but unfortunately it's going to sell better if I write it in Ruby. And I went, well, yeah, I understand the commercial imperative. I don't have to like it, but I understand it, and I totally support that. And so he wrote his next thing in Ruby. You might have heard of it, because it's called Chef. So yeah, I would say of the improvements that Chef makes over Puppet, if you like Chef better, 2/3 of them are because Holloway is smart, A third of them are because he was stupid enough to argue with me for days. And there's a fourth third that would have happened, except I couldn't convince him that those were improvements. The man was fucking cool though, I'm not, you know. Anyway, because you have this whole ownership issue. Chef and Puppet both assume that they own the system they're working on. Okay, for production platforms, and by the way, this is where Holloway and I disagreed, because he'd been at friggin' finance companies that were audited up the wazoo. So in their case, if somebody made an unscheduled change, that was an HR problem, not a technical problem. That was a serious issue. Whereas in my experience, if somebody makes an unscheduled change, either it's 3 AM and they're trying to get production back up, or the more traditional cases, it's a dev box, right? If it's a dev box, the automation system cannot own it completely. I mean, Shadowcast dev box gets abused in so many ways. I mean, I'm not sure I could write a statement of conduct that wasn't violated by what happens to the average dev box per week. Because, you know, this is the machine that is there to be messed about with. You know, you have a customer who goes, oh yeah, we brought up a staging instance over there, but our DNS isn't working. Fine, we'll edit the host file in the dev box. This is, you know, whatever. It's a dev box, it doesn't matter. But the problem is, of course, your systems automation code goes, that isn't standard, smack, override. After about the 3rd time this happens, 1, you work out what happens, 2, you kick yourself for not turning the automation stuff off first. 3, you then realise that unless every time this happens you remember to turn the automation stuff back on, you're going to end up with development diverging from production. And development diverging from production is not a happy thing, as I'm sure we all know. So in order to be able to spot this stuff, make minus n. Make. Okay, I know. It involves, in spite of not being Python, it still has significant white space. It's old, it's annoying. Make, by the way, is the ultimate example of the curse of backwards compatibility. The guy realised 3 weeks after he'd first released it that using tabs was a terrible idea. But he had 5 users at that point and didn't want to break compatibility for them. In hindsight, he's aware of the irony. But the minus n part is really important. Make can tell you what it's going to do before it does it. And it does that based on looking at what needs updating and what doesn't and giving you information. But yeah, I have a slide called overwriting. Sorry, traditional thing. If I've not written the slides 2 hours before I gave the talk, I forget what they mean. Don't worry about this. Anyway, the point of this is the current systems do a lot of overwriting stuff. I'm going to go back to the make minus n slide and rant about how much I hate everything. Because here's the thing, right? When I was at the German Perl workshop, I was giving a tour of the MakeMaker internals to people, yeah? And I thought, okay, I have to think of something to say about module build that isn't offensive. I'm like, okay, why would you have a build.pl script? Well, you know, you were dropped on your head as a child, you hate everybody, come on, there's got to be a reason for a distribution on cpan to have a build.pl script without it just meaning the person who uploaded it is a moron. I had to find one, even if I didn't believe in it, so I went, hang on a minute, dmake and nmake, terrible. So I went, so maybe if your main target is Windows users, writing a build.pl is actually sensible. And now bear in mind, Germans don't heckle, right? They don't. 3 German sysadmins stood up and stood there with their hands raised until I acknowledged them and said, actually, you're wrong. Demake and endmake are ugly, unpleasant and slow, but they have a -n switch and module build doesn't. And that means we can debug them when they fail to install. So please, the Windows sysadmins in the building say we would rather suffer make than suffer module build. Please correct your talk in future. Which I thought was fascinating. By the way, module build tiny is actually exempt from all of my hatred because it was written by people who actually understood Perl. But yeah, every time I look at every time I see build.pl in a distribution, I think, oh, this isn't going to install right because it involves module build. I shall now budget an extra 20 minutes for getting my things dependent on it to work. Anyway, so yeah, the overwriting problem. Puppet and Chef go, your entire system is mine. If, you know, if there is one line in your config file you want to add by hand, you are wrong. You must add it to the centralized config. You know, in Soviet Russia, all network cable 3 meter sort of situation. And it's all very well, but you have the, this is a one-time change problem. You have the, it's 3 AM and production is down, I don't care how it's supposed to be automated, I just want to fix it. And you have the Devops problem. The other thing is, they all assume that all automation is within their grasp, right? They have more of an ego than I do. That's achievement, right? So to those systems, anything they can't do is out of scope. Whereas from my point of view, if it's a full systems automation system, why can't it go, actually, I don't know how to deal with this, a human needs to deal with this, I shall send a ticket, suspend my current continuation to disk, and then wait until the human being says, yes, I have installed and racked that machine, you are now allowed to continue fucking with it. This should be, again, it's not hard, it's just you have to think it in the first place. Anyway. Next is fascinating. Seriously, look at this piece of code, it's amazing. They have done a pure functional build system. They've actually built an entire Linux distro on top of it. It's beautiful. I mean, it's so cool. The GNU project have forked it, stuck a G on the front, and done a wildly impractical version of it themselves. Which, you know, the wildly impractical version I'm not suggesting you use, but seriously, you know, if it's awesome enough for them to do that to you. Anyway, so the idea is fantastic. It is pure functional. Every single package it installs gets basically installed to its own SHA-1 directory. The thing I was disappointed about is Nick still relies on a channel. But what I mean by a channel is, at any given point when you do an install operation on a Nick system, you have an upstream set of packages which lists, these are the available packages and these are the current versions to build and this is how you build them. Well, being able to do pure functional build system over that is awesome, but I was so disappointed when I discovered that which versions are valid was still curated by a human rather than code. Because dependency resolution is something that fascinates me. Because, you know, okay, you know, given Shadowcat's basic friggin' business model is we employ maintainers of several CPAN things that you have in production, hire us to help you use them better. We tend to work with customers who have a lot of dependencies in production, yeah? And I'm kind of the resident deployment specialist because, as may be becoming obvious, I am not a sysadmin, but I can fake being one in the absence of a real sysadmin better than most developers. So, you know, dependency resolution is really important. And with a channel, you miss the fun part, which is something like, you know, X needs 1.1 or up of something. Y needs 1.0. That's easy, you just resolve that to the latest version, yeah? But if Y can't use 1.1.12 because there's a bug in it, now, to quote stilldrinking.org, now everything is made of urine and you can't even find the cat. So you need to be able to do multiple copies of things. This, by the way, is part of my long-standing journey towards hating everything, including myself. Because I looked at all packaging systems. DPKG is my favourite packaging system, except it can't handle multiple copies of things, and it probably never will. And the reason is, I went back 4 years ago, they had an idiocy problem. Because somebody said to them, here is how I will add support for multiple versions of the same package installed at once on Debian. But at the same time, you are wrong about everything, and here's how Debian needs to rename every single package in Debian in order to agree with my genius. As you can imagine, this person was told to go fuck themselves. Unfortunately, that now means every time you mention the idea of wanting multiple versions of a package installed at once, the DPKG developers remember that person. And then it doesn't happen. It's basically the same problem you have in the Perl community, and proposing an idea that is correct, but Mark Lehman proposed already. It's one of those, no matter how technically correct you are, politically it ain't going to happen. I discovered, actually, RPM supports this fine, which is a great shame from my point of view, because it supports that fine, but it's still RPM. Anyway, another thing that I explored that's fascinating, BPEL. BPEL is one of those giant XML standards that came out along the same time as SOAP. It's an orchestration language. It's a fascinating idea because it's designed for web service orchestration, including the idea of dealing with orchestration and rollbacks across systems that aren't transactional. So it has the idea of a compensation action, right? Wherein, if you need to send SOAP calls to 3 different systems and one of them returns an error, you need to then send calls to the other 2 going, haha, actually, only joking, sorry, don't pay them money, or whatever, you know. It's designed for that sort of system. But I found the concept fascinating because it comes back to the whole -n thing. Yeah, a lot of the time you can say this is what I'm going to do before you do it. But there's situations you get into with systems and operations where the only thing you can do is try it. And if it doesn't work, roll it the hell back. So I've been looking at this, and So I will confess, I am a pure math major. Haskell still seems weirdly, overly mathematical and incomprehensible to me. It's an awesome language, but I can't quite get to the point of writing it. But monads are awesome. I beat my head against the concept of monads for about 9 months, and then went, I understand this. This is amazing. There's an entire rest of a programming language here that I still don't understand. This is amazing. Learning Git for me was basically beat head against brick wall for 6 months until blood or enlightenment results. I've been administrating SVM for years. Maybe it caused brain damage, whatever. After the 6 months, I fell in love with Git and refused to use anything else. So, you know. The key takeaway of monads for me was they handle side effects by saying you have a function that takes a state of the world and returns a new state of the world. Right? And in that, you then hit, this is still, this is still pure functional now within the program. But, you know, in the process of going from old world to new world, a line has been printed on the console or whatever, which is, you know, in Haskell, that's so side effecty that, you know, Haskell core goes, oh my god, you're changing something, that's not functional, that's not functional, that's not functional. But this conceptualization allows it to meet you somewhere in the middle. It's a brilliant approach. And given my desire for working -n for everything, I thought that was awesome. So I fell over Prolog. Prolog is the French came up with it in the early 70s. And it didn't catch on. Now, given the things they were doing with the French as a whole were doing with cuisine and body hair in the 70s, I'm glad most of their inventions from that decade didn't catch on. But Prolog's actually really cool. Because Prolog has the idea of a predicate, right? Yeah. The idea is, so installed server package, yeah? That's not a subroutine, it's a predicate, that's important, and those two are variables, right? What it's talking about is the truth of this statement. And it tries to look for a way to prove this statement true. If you call this, you call it with server bound to a value, it will return once per package installed on that server. You call it with package bound, it will return once per server it knows about with that package installed on it. If you call it with both of them bound, it'll return true or false. It's the capacity to look at the world in those different ways with a single expression is really interesting. Okay, in the case of my problem child customers, it's not so much, you know, which packages you install on the server is nice, but which packages are 4 versions behind on security updates is the scary part. However, those of you who are Madison may recall me talking about an introspection system that was discovering that stuff. This is part of my ongoing research as a result. Anyway, TCL, oh wow. Man, TCL is probably my favorite piece of technology that's been declared dead more often than Perl has. Seriously, TCL really does believe in everything is a string. Even objects and whatever do have a required canonical representation as a string. So yeah, it is pretty much Lisp except made out of strings instead of lists, and I have a lot of respect for the developers. Because they got declared dead and got on with it. And also, this is one of my tests for programming languages. If it doesn't have an unless keyword, I try and figure out how to write one. This is what happens when you're the child of two English literature graduates, right? You get obsessed with the linguistic bits, whatever. Took me about 3 lines to make that work. Because, remember I said everything is a string? You see that brace? That's a single quote character in TCL. The way it handles metaprogramming is, braces are actually a single quote character. So that, the body of the unless block, or of an if, or of a for loop, or whatever, is actually just a string that you call eval on. Except in TCL it's designed for you to do that, so the moment you do that it caches the compiled version alongside the string, and then it's just as efficient as anything else from then on. So it's not, basically string eval in TCL is not evil the way it's evil in everything else that has string eval, because in TCL everything is a string, so calling eval on a string is no more evil than calling eval on a list in Lisp. I was originally giving this talk at UK Unix users group. So I had to make the traditional explanation of why have I written this in Perl? Well, because it's better, dumbasses. But to an audience of sysadmins, obviously you have to be slightly more convincing than that. This is my basic explanation. Seriously though, every time I try and use Ruby or Python, I go, this is cute, this is cute, this is cute, this is cute. I need to do some OO now. Wow, this is more typing than Moose. I'm bored already. Let's go back to Perl. To the point where there is now, again, an effort to port the move feature, the move subset of moves to Ruby, and there's apparently 2 ongoing efforts to port it to Python. So, I had no idea, but the audience told me. So it turns out that M*OO systems are addictive even if you're not writing Perl, which I thought was hilarious. So people keep trying to port them to other languages. Anyway, going back to make. I hate tabs. I already explained why it still has tabs. It's hilarious and tragic. But debuggability is amazing. Because if something goes wrong, I can run make-n and go, what were you planning to do? Tell me all of it. And I can usually see where it's gone wrong. Predictability, again, I can tell it, what are you going to do? Also, I can do heinous things. I don't think I have a slide for this. When I've been in a situation where I have to get a build of a piece of software done today, one of my favorite things ever is, okay, I have beaten their configure thing with a stick until it did most of the things I wanted, but there's still one compiler flag it's missing. And this is an obscure compiler flag, but it's required. I spent some of my formative years administrating things like Solaris and HPUX. So having a required compiler flag that the author of the software I was trying to build had never heard of was one of those things that happened to me. And what you do is, you do make-n pipe, and you throw it through a Perl one-liner that does a substitution regex on the GCC commands and adds the flags you want, and then you pipe the output of that into sh. And it's horrible. But the software builds, you can document it, and you can go for a bear. And you know, at the end of the day, so long as you've documented it, so the next person goes, oh, what did you do? Why? Oh, it was Matt again. It's still an improvement over not having that package available in production. I was never afraid of having dependencies. But the systems teams at several places I worked were afraid of the things I'd do to get dependencies if they didn't do it better for me in advance. Anyway, so yeah, you're using what is a common thing for me. Perl people often don't seem to get TCL. I think it's beautiful. TCL people definitely don't get Perl, although given they've been subjected to a lot of language hate, a lot of them go, you know what, each to their own, because language hate is stupid. Haskell people are disappointed that everybody doesn't understand Haskell. I understand the point. And then prolog people, wait, there are still prolog people? Actually, there's a channel on Freenode. It has about 6 people in there, as opposed to the 600 of Hash Perl. But they're all quite smart and very interesting to talk to. Fundamentally on hash prolog, other than the people who are there because they have homework to do, I'm the stupidest, least knowledgeable person in there. And you know what? It's actually really quite fun to be that person for a while for me. So yeah, seriously, if you play around with prolog, that channel's fantastic. Just ignore me because I don't know what I'm talking about. Anyway, so the idea was to have a solver system. Now, okay, what do I mean by a solver? I want to be able to say to it, an execution environment satisfies a requirement if a build exists such that that build can satisfy the requirement and the environment contains the build. For those of you wanting to follow this along in a slightly more concrete fashion, think, right, yeah, okay, now I can see what I fell over. That's wonderful. I'm sorry, I've had 2 days of falling over things and thinking, hey, I'm just an idiot. No, wait, there actually is a landmine on the floor. Normally when I fall over things, it is just me being an idiot. Anyway, for following along, consider environment to be a local lib, potentially. Requirement to be a package plus version for a meta.json. And build to be an install of a cpan package. That's my standard model, but the point is it's a bit more theoretical. Transitive dependencies get fun though, because you know if you're trying to resolve things in advance, you have to care about the dependencies of your dependencies. So you handle that by going can satisfy and contains, and then for each requirement of myself, and the reason for having a requirement of build with that, it also needs to satisfy that. And that pretty much expresses what apt-get or cpan or whatever is doing to get you a complete set of software. But the interesting part is the output. The reason I'm doing this as a solver is, okay, the output starts off as either true or false, as in, is this stuff already installed or isn't it? But it can also output maybe. Now, you would think that in systems administration maybe is a terrible idea, but it turns out that maybe is the most important concept you will ever come across. Because what maybe actually means is false, but. The idea being, it's false unless you install the missing dependencies, at which point it's true, right? So it can actually output possible solutions. So the idea of this is, if you say, solve for this piece of Perl software has its dependencies installed, it can give you a possible solution of install those dependencies with apt. Or it can give you a possible solution of install those dependencies with cpan- into a local lab. And those are both first-class solutions to the problem you pose to it. So the idea is you basically have values and actions. Actually, on further consideration, due to the traditional thing of the moment you give a talk, you realise all the design mistakes you made, it turns out that actually setting a value is a subset of executing an action. It's just that setting a value is an action that doesn't have a side effect on the external world, only on the internal world of the solver. But we'll continue with this. So you end up with a projected result, yeah? Prolog, you have a fact database and a logic query, and it either goes, you know, if X was set to 1 and Y was set to 3, your query will be true. That's really cool. What this is meant to do is, if X is set to 1 and Y is set to 3, your query will be true after you install the patch on this server that is missing it. And that's where I'm going. This is why I was talking about monadic stuff. So the idea is solve gives you possible solution and projected result, and then you execute the first action, rerun the solver stuff, double check it still says you're going in the right direction, run the next action and keep looping until the service is up. I mean, more honestly, you can run independent actions in parallel. So if you've got a job of install a patch on these 3 systems, you can run them all at once. Whereas if you have an action of create this directory and an action of create a file in the directory, obviously you need to do the mutdir first. So actions have a dependency system. And then you just keep, so you run the independent ones, you rerun the solver, check it's still going in the same direction and keep looping. So the thing I built on top of my last prototype for this is an SSH key manager, which obviously I called key mangler because what else are you going to call it? And so you can, by the way, just a second. There we go, now it's on screen again, projectors. This, by the way, is actual TCL code, copied and pasted out of the rule file, and it goes through a couple of TCL-based translational layers, then discovers it's part of TCL.pm and is embedded in a Perl VM, and eventually turns into Perl array refs and gets fed into my prolog-ish VM that's written in Perl. So 1, that's real life syntax. 2, the TCL part isn't required, I just find it less ugly than everything else I've tried. And I'm damned if I'm writing my own parser and compiler unless I have to. But yeah, so this rule is talking about, do you have a .ssh directory? So it has a beacon, that figures it out, $home and /ssh. Well, that figures out $home. That goes, this is .ssh, that double checks the mode, right? Simple enough, but bear in mind .ssh dir is unbound when you enter this and becomes a bound variable in the process. Now, prolog could return true and false from this. The solver can return, you haven't logged into this machine before, I'm going to need to mutdir and chmod.ssh for you. At which point that's an action of create directory. Or if it's already there but has stupid permissions, you get an action of chmod directory. And then you build a rule on top of that for authorized keys that uses the .ssh one, says we need this file. I have no idea why there's a T in authorized keys there. Also, it's gone off screen again. There we go. I love this slide system, but occasionally it trolls me. And then on top of that, you build a rule for key install log. So contains line can return false or true, or false, but it will be true if you append this line. So when I say I want these keys installed on all of these machines, it returns true for the systems that are already set up, and for the ones that aren't, a combination of mkdir and append actions. Which is just really cute. And the interesting thing is, the same concept, because this can work to take actions or not, I built the configuration system out of it. So I have basically a config file thing that resolves a type of config to a particular path within my /.key mangler. And then I can use contains line on it, which means I can have interactive commands to add entries to my config that use exactly the same mechanism as the automation code that's adding things to remote systems. Which is, in terms of not repeating myself, is awesome. So you have three modes, basically. Query is the traditional prolog, true or false. Solve is true, false, or true if. And then ensure is the mode that actually runs the actions. So I can basically get all of my keys distributed by going, for every key I know about, make sure it's installed on an account. And the other nice thing is, query mode lets me do a status command with the same code that does the installation. This is really nice, because one of the things I've suffered many times in the past is, I have code that's supposed to install something on a system, it contains a bug, but returns true. The way this thing's built, you first have to say, how do you determine if something's installed? And if it then has to go and install it, it runs the check again afterwards because it doesn't trust itself, which I think is very important for a systems tool, especially one that I wrote. So you have sync as a command that actually moves keys, but -n is always there. It always has to be, because the solver has to be able to tell you what it's going to do without doing it, and then doing it is separate, which is the one thing I got from a Haskell. Any Haskell people in the room, please shake your heads at me sadly for the fact I didn't understand all the other things that are awesome about it, but that one thing was totally worth it. So you can pretty much literally run that at the console, and it does the right thing. So coming back to that, I hope you can now say how that would be sufficient to drive a CPAN build system, which is one of the things I'm planning to build on top of this. As a test, I am about 1 minute from being out of time and therefore delaying whoever's next in this room.
Lunch.
And oh right, so I'm just keeping you from eating. Oh, that's fine. I don't care about your feelings, you're not speakers, right? But the interesting thing is, because prolog backtracks when it runs into a problem, that sort of clash is built in as it just goes, oh no, well, best try another value for the version of this library, I'll just go back and try again. Which is why it's all continuation parsing style. But it's just built in. You know, most dependency resolvers, when they hit that problem, go, conflict in dependencies, go figure it out yourself, puny human. Whereas the prolog model just goes, oh, that's a conflict. Well, that's okay, I'll try 1.1.11 instead. And you know, the host file problem is basically, it's going to work. Because if you specify it as it needs to contain these lines, rather than this is your entire file content, that means you can add things from your systems automation solution without overwriting the entire thing and wiping out local changes. What I'm really interested in is taking Ingy's PegX module and building grammars using that preserve white space so the solver can reach into a JSON file in a Git repository and add a single value to a deep key in a way that still diffs nicely. I have not implemented this yet, but I am 98% sure it will work. On git.shadowcat.co.uk there is a repository called dkit, which contains the current prototype towards this. It is almost certainly going to get violently forced pushed at least once before I actually like the code. So while I encourage you to investigate it in order to see where I'm going conceptually, I wouldn't try and use it for like real work yet. This is like prototype number 12. I've been thinking about this for a few years. But I think the idea of prolog plus actions is a really nice model for this stuff. And hopefully I will be standing in front of you next year going, by the way, you know, last year I said, I think this is going to work. It did, and this is what I built with it. I make no guarantees, but that's where I want to be next year, you know? Hopefully, in spite of being a bit rambling and not having a particular point, this was interesting. Thank you very much.